Welcome to this explainer. Today we are unpacking a literally mind-bending paper. We're looking at a breakthrough that takes the biological mechanisms of human consciousness, how our actual physical brains work, and translates them into a solution for blockchain's biggest security and scalability problems. It is a completely fascinating collision of neuroscience, quantum physics, and cryptography.
We've got a wild roadmap today. We'll start with the mystery of consciousness, look at the current bottlenecks in blockchain, cross over the bio-inspired bridge of the ORCHID protocol, watch how the quantum network synchronizes, see how it smashes classical limits, and finally, look out at the post-quantum horizon.
All right, Section 1, the mystery of consciousness, unifying the mind. We're actually kicking things off not with computers, but with the fascinating architecture of the human brain.
It's a universal mystery that neuroscientists call the binding problem. Think about it for a second. You've got millions of independent neurons firing all over your brain, right? So how do they suddenly agree on a single, unified reality in your mind? How do those completely scattered signals suddenly become one conscious perception?
Well, to answer this, neuroscience and quantum biology point to something called the Orch OR hypothesis, developed by Roger Penrose and Hameroff. The idea here is that tiny structures inside your neurons, called microtubules, achieve quantum coherence, meaning they suddenly act together as one single, unified system. They phase sync and collapse at a timescale of about 40 Hz, that's the gamma band, and that synchronized event is exactly what creates a unified, conscious perception out of total chaos.
Moving to Section 2, the blockchain consensus bottleneck, the digital dilemma. Now, let's make a hard pivot away from biology and over to the architecture of distributed systems.
Modern blockchains are struggling with their very own binding problem. Reaching agreement or consensus without failing or slowing down is a massive bottleneck right now. Proof of work, which Bitcoin uses, wastes enormous amounts of energy and drags along at about 600 seconds per block. Practical Byzantine fault tolerance, or PBFT, guarantees safety, sure, but it requires an exploding number of messages, scaling quadratically, which basically bogs down the whole network. And alternatives like hot stuff scale better, but rely on a single leader, creating an obvious point of vulnerability. So the crucial takeaway here is this deep, mind-blowing structural parallel. On the biological side, distributed neural oscillators synchronize to form a unified conscious percept. On the digital side, distributed blockchain nodes synchronize to agree on a single ledger state. The biological brain and the digital distributed ledger are fundamentally trying to solve the exact same problem.
Section 3, ORCHID, the bio-inspired bridge, translating biology to code. To actually operationalize this incredible connection, researcher Itzhak WEINBERG introduces a truly radical new protocol. Enter ORCHID, Orchestrated Reduction Consensus for hash-based integrity and distributed ledgers. WEINBERG's protocol literally uses the brain's hardware as the software blueprint. It completely abandons traditional voting rounds. Instead, it outfits every single blockchain node with a quantum noisy phase oscillator. It's modeled after the Kuramoto synchronization equation, which is a mathematical model that explains how independent things, like fireflies in a dark forest, just spontaneously sync up their flashing.
Because there are no explicit voting messages going back and forth, ORCHID nodes follow an emergent synchronization trigger through 3 distinct states: broadcast, accumulate, and commit. Let's look at exactly how this bio-inspired machine operates.
First up is Step 1. Just like a single neuron firing in the brain, an individual node broadcasts its phase beacon into the network. It's not sending a vote, it's simply projecting its current oscillating rhythm out to its immediate neighbors.
Next is Step 2. The node accumulates messages from those neighbors. But again, it's not tallying votes. It's computing the local mean field order parameter. In everyday terms, it's feeling out the collective rhythm of the network immediately around it to see if the phases are beginning to align into a single pulse. Finally, Step 3. When that network synchronization crosses a highly specific mathematical threshold, the node immediately commits to the majority value. It's an emergent trigger, perfectly mirroring a conscious binding event in the human brain. At this exact moment, it also distributes cryptographic puzzle pieces, utilizing a mechanism called quantum secret sharing to securely lock in the data.
Section 4. Synchronizing the quantum network, the math of consensus. We've talked about the concept. Let's look at the actual data to see how this mathematical synchronization behaves in practice.
When you track the synchrony of the network, something amazing happens. You can watch as completely scattered phases suddenly snap into a unified rhythm, hitting a binding threshold of exactly 0.75. Boom. Once it crosses that threshold, the network has achieved consensus, and it did it without a single explicit voting round. Underneath this, there's that quantum secret sharing module we mentioned. It secures the ledger based on the quantum coherence of the network. What's wild here is that the moment network coherence hits roughly 0.82, you get a razor-sharp transition to 100% fidelity. Below 0.82, it's just noise, but above it, you have absolute mathematical certainty.
Section 5. Smashing the Byzantine limit. The experimental climax. We've seen the theory, but get ready, because this is the absolute mic drop of the ORCHID simulation results.
Classical distributed systems have a hard safety limit. If more than 1/3 of the nodes are malicious or failing, what we call Byzantine nodes, the entire network breaks. However, ORCHID mathematically obliterates that traditional limit. It maintains a 100% consensus success rate even when faced with 40% bad actors. Because the malicious nodes are physically pulled into the phase synchronization of the honest majority, their bad data is just completely overwritten at the exact moment of commitment.
When you stack the numbers side by side, the performance difference is staggering. ORCHID's median convergence time sits right around 2 to 4 seconds, vastly outperforming the slow 600-second block times of proof of work. Plus, because it uses emergent synchrony, it entirely avoids the massive message overhead that clogs up PBFT protocols.
Section 6. The Post-Quantum Horizon, Scaling the Future. This brings us to the ultimate question of network scalability for post-quantum distributed ledgers.
Because ORCHID only requires neighborhood messages, literally just checking the rhythm of the nodes immediately next to it, its complexity scales beautifully. It grows subquadratically, cleanly overtaking those clunky exponential PBFT models as the network grows to 150 nodes. It proves that bio-inspired quantum consensus isn't just a neat academic theory. It actually scales better than the systems we are relying on today.
Which leaves us with a truly provocative reality. Weinberg's work essentially proves that the exact biological mechanism allowing human consciousness to exist can be coded to secure a global digital ledger. As biology, quantum physics, and cryptography fully merge, what else are we going to learn to orchestrate? Thank you for joining me for this explainer. I really hope it sparked your curiosity as much as it did mine.